Welcome back, grade 9. Today we are going to start our chapter 2.3 using space technology to meet human needs on Earth. We are going to learn first part of it and we will probably end somewhere midpoint of GPS system. So let's start with our video first. This video talks about hazard of human space flight, hazard number 2. The first one was radiation. Second hazard is what we discussed, more psychological part, isolation and confinement. So if you remember my instruction, people who have a lot of phobias or psychological instability, they cannot even pass the test of being astronaut because they will fail the psychology test. Now, instructors, please, whomever the substitute teacher will be, please pause this video and search from the YouTube, hazard of human space flight, hazard number 2. It's about 2 to 3 minutes. All right, let's talk about our terminology first. You may hear about the satellite dishes, or the one that people say about satellite, which is what you can see from over here. When it comes to satellite that we are having around the Earth, there are so many nowadays. We're going to go through some important one, but the word satellite actually came from anything that rotate. This is more definition. Anything that rotate a planet. So we have a naturally formed satellite that rotate around us, which is Moon. Today we are talking about artificial satellite, the technology that humanity has developed and how that technology is used as a satellite. One of the important aspects of using satellite is GPS system, mapping, and so on, but there are a lot of stuff. Yes, there are a lot of controversial stuff that government did not disclose to public yet too. But we are not talking about Illuminati in this class. We're talking about more of a technological development and how we use those. One of the main purpose of satellite is communication satellite. Back in the early 20th century, telegraph and telephone messages travel through wire, especially the telegraph. And when you look at those, this is a little bit after Morse. Actually, Morse is over here. The one that goes doot 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 doot. What I just did was SOS signal that what was that ship? Titanic ship actually used it. Long story short, the signals go electronically. Signal. And you use a little bit of wave signal, which is a touch of the Morse. You also have an experience playing with the cup communicator, the one that has a string attached, because string can send the wave energy from one end to another. So long story short, 20th century, we had to have some kind of mediator. On the other hand, when it comes to digital signal, now we're talking about 21st century more, we are relying on the radio wave, which is one of the wavelength the EMR has. EMR stand for electric magnetic radiation. You learn about that in grade 8. However, we're not going to go entire thing about that, but long story short, EMR is the one that use radio wave. Under the EMR spectrum, radio wave is one of them. This is the one that has highest wavelength, so it can travel far, but low frequency, so it's still safe enough. It doesn't have any powerful radiation strength about it. So, digital signals from satellites allow clearer transmission and a large number of users. It is available to receive a signal and send the signal, and it's done by radio wave. The application of that is actually Wi-Fi. Wi-Fi use radio wave too. Also, Bluetooth. Except those devices, wavelength is controlled to be short. So when it comes to Bluetooth, you're one of those wireless headphone probably cannot receive your signal if you're about 10 to 20 meters away. Also, another satellite function other than telecommunication is obviously observation and research. It does two different types of research. What's going on Earth, or what's going on space, or inside of the space, if you will. Maybe I should have. Earth and space. The one that we are going to talk about is specifically geosynchronous satellites. The word geo and synchronous, I'm going to divide this word by two. Anything geo is land related. So in this case, geo means Earth. Synchronous, the word sync means match. So if you look at the word, deconstructed word little by little, geosynchronous satellite it is a satellite that matches to the Earth. How do we match to Earth, or what do we match to Earth? Well, remember, Earth rotates. And at the same time, Moon rotates. And Earth itself rotates around the Sun. So geosynchronous satellites are those that maintain a constant position that are used to monitor what's going on Earth, specifically for weather. And if this is not synced, we cannot receive and send the data that is observed or that are observed by the satellite that go around the Earth. So when it comes to the angle, obviously specific calculation should be happening to talk about gravitational force, and at the same time the axis, angle, all of these has to be calculated. So geosynchronous, as you look at from this red or oval shape over here, you need to think about little inclination of the angle so that it doesn't interact with moon and other type of asteroids, but at the same time maintain enough that the message can be received and sent to whatever institution, mostly government institution and NASA, and it can be shared. The other satellite, one that I like to say Landsat and RadarSat, can track several other detail that is happening on the Earth. One track about ships at sea. Nowadays, by the way, we are at the fourth industrial revolution, and a lot of AI and tracking technology will replace these. So satellite can be used for something else than tracking. Forest fire, natural event, and environmental damage, natural resources, all of them are tracked by Landsat and RadarSat. But at the same time, this is my little theory. A lot of satellites is used for military usage. For example, South Korea and North Korea, we have a demilitarized zone, and then we are constantly monitoring what's going on around that area. We also cannot ignore, since we talk about communication or a communication satellite, anything that involves remote sensing system play a huge role. Remote sensing has a lot of purpose. It has a lot of things to do with the general broadcast to navigation system, any type of receiving station that have satellite dishes from an observation satellite. There are so many that you can think of. However, one thing that we need to know in grade 9 is we're using EMR, electromagnetic radiation, specifically radio wave, and it's the one that go return way. What I mean by that is, imagine if you send the signal, send a request signal, you will receive it. And it's done by speed of light, which we're going to do a little calculation, by the way. The main purpose of satellite in low Earth orbit, which is 200 to 1,000 kilometer altitude, is to make observation about the Earth. Let's see what remote sensing provides. If you look at it, there are a lot of sensing that is relying on for Earth observation, some of them technology use, and scientific use, communication use. This is about 10 years ago. If you look at just a few years back from 2022, look how much is used. A lot of them are actually used for remote sensing and Earth observation. There are definitely reduced amount of communication. In fact, nowadays we can have a unlimited data in clouds, Google Drive, and in your phone. Unlimited data can be used using current technology. However, policymakers and government did not decide about its bar yet, so that the company cannot monopolize something like that. But technology is there. But in any case, if you look at remote sensing, number one, it provides information about the condition of the environment. Natural disaster, human-caused disaster, it does sense everything. It also senses temperature differences too. That's how the forest fire can be detected. Natural resources, which is a big part of it. Natural resource that can be gathered under the sea or any type of trench area is still being observed using waves. Sometimes it uses a submarine systems, but it is costly. And there's the effects of urbanization. What I mean by that is, for example, carbon emission. Sulfur emission, and so on. If you look at this picture over here, it does show several aspects of how the satellite's being developed from 1999 Shenzhou all the way to the new version of it. And this is one type of satellite that is constantly being sent outside. Practically, you don't know about this, but space around Earth specifically, it's already full of debris and then a bunch of garbages that is the remnants of old satellite, let's say destroyed by asteroids or even just not function, something like that. It is being dumped. Today's last portion, we're not going to go through everything, but we're going to talk about Global Positioning System, GPS. There is a video related to that too. There are about 24 GPS satellites that orbit the Earth. However, this 24, ladies and gentlemen, it's an old information. I do not know how many are rotating right now. But at the time that I was making this PowerPoint, there were about 24. At any point, there are at least 3 of these satellites that are above the given location at any moment. And the thing about this 3 play a huge role, because when it comes to GPS system, we technically use something I like to call trilateration calculation. And the word tri means 3 in Latin. It's a common prefix that math and science use. So that means, imagine there's a GPS 1, 2, 3, and there's a target. It actually use 3 GPS location like a Bermuda Triangle, and we do calculation. The Global Positioning System GPS produce radio signal. Like I said, the one that has high wavelength and low frequency. It is a part of an electromagnetic radiation. That's all you need to know about this radio signal. But long story short, the radio signal is picked up by receiver, and the speed it takes about speed of light, which is about 3.80 meters per second. And these signals contain digitalized information. The one they use binary system 1 and 0. So this is a picture. 24 GPS satellites ring the Earth at 17,700 kilometers away, and it received the signal from 3 of them, which is the one that I mentioned, trilateration system. And using this 3, and I know it's not Pythagorean theorem per se, but using the trigonometry and other skill that you're going to learn in high school, we are able to calculate the receiving signal and send the specific signal of the location of your vehicle, if you will. It shows up. The GPS positioning system, let's talk about the time. The time information from each satellite is compared with the internal clock on the receiver, and the time difference between the signal indicates the distance from the satellite. What I mean by that is this. I'm going to talk about that in the next example, but let's say you learn about this formula. Speed is equal to distance over time. V is speed, D is distance, T is time. Generally, speed in meter per second, distance is in meter, time is in second. You can change that into kilometer per hour, kilometer per second. Then if you do that, distance should be changed into kilometer, time should be either second or hour. So this formula is simple. Internal clock, sometimes we call it quantum clock, is this. On Earth, in your classroom, if I ask Aaron about the time, he will say the time. If I ask Noah, he will say the time at the same time. But imagine you don't use your phone as a time, but use a watch if you have it, like wristwatch or the clock inside of a classroom. Nothing is precise. So internal clock actually use absolute speed that we can think of, which use speed of light. That does not change its value. Using that, we can compare the time, and we can actually locate and predict how long it will take for you from destination A to reach to destination B. It's just complex calculation, but the formula itself is easy. So let's do this as an example. Let's say this is our good old Earth. We have, let's say, Mr. Allen, BA. And we have our satellite that I tried to draw. There's our satellite. Imagine, even though, yes, in our actual satellite system, we use trilateration system where we require 3 of them, but let's scratch that idea. Let's just talk about one satellite and how long it takes as a signal to reach. If you think about the signal, let's say Mr. Allen's trying to check his time. He needs to send the signal, and he has to receive the signal. In order to do this, you need to understand that we have to have both going and coming back time. Let's say the distance between the satellite and the person who like to go through is about this much. 20,180 kilometers. Speed of light is given in this way. Well, then let's convert it. Kilometer into meter. All we gotta do is just multiply by 1,000 So 20,01800 meter. That it's the distance. Now let's think about our formula. V is equal to d over t. We're trying to find out the time that it received for Mr. Allen to send the signal it received. Then if I rearrange it, I'm just gonna switch V and T, aka multiply by T on both sides and divided by V on both sides. So long story short, T is equal to D over V, distance over speed. And all you gotta do is just punch these numbers in. The number is the only thing that is big enough. So it's 20,180,000 meter. Velocity is 300 million meter per second. All I gotta do now is take out my calculator and punch these numbers in. 2018000 divided by 30000000000. Then you will receive about 0.0673 seconds. Now know the fact that that's one way. So if it's going one way or coming back, you need to multiply by 2. So it takes about 0.135 seconds to do the whole sending and receiving. And that is pretty short time. That is one way of dealing with it. No wonder why GPS update every single time when you move. Now for this part, we can take a little pause button. And instructor, I want you to play this video probably after the exit slip. How does GPS work is what you can search in the YouTube to play. So ladies and gents, right now it's an exit slip time. Please check your Google Class. You did this before. Log into your Google Class, do the Google Form exit slip by clicking the link. Once it is done, take a rest until the instructor play the video once everybody complete. You do not have a science homework for today. Thank you.